Welcome to Advanced Chemical Analysis. This is CHEM 311, and my name is Dr. Samuel Mugo. You can call me Sam, and I'll be your instructor for this course this semester. I hope all of us, had a good holiday break and we are rested and ready to embark on this new semester. So in this lecture, I'll just largely go through some of the course expectations, and that way we're gonna get everyone started and comfortable to know what is expected of them in this particular course. Now, I always like to start, with these slides, on what are the student expectations, for this course. So the question to you is, why are you here? And how do you intend to have this course maybe fast track, your path to the different career choices on where you are going? And I hope, most of you guys know where you're going. And so if you don't, of course, I hope this course is also going to help you towards that direction, helping you know where your passion lies. And so take a moment really, to think on that question, why do you really want to take this course? And what do you intend, to actually, get out of it? So in our session tomorrow, that's January the 7th, that's a meet and greet session. Like each one of us really, to share, why they are taking this course and what their career aspirations are. And the reason I often do this is to hopefully, personalize the learning, and things like the assignments and so on can be personalized, towards each student's individual path, to where they want to go. So again, January the 7th, planned to share on, the your major and why you're taking this course, what you hope to get out of this course, and possibly your trajectory, as far as, your career is concerned. And my goal really is to help students, towards the different career paths, they hope to embark on. And so I emphasize the need, for every student really, to learn with a goal in mind. You guys spend a lot of money to pay for these courses. And so as such, it should be an investment. It should be able to help you fast track or maybe even accelerate, your pace to the career path of choice. And so I hope as your mentor and of course the peers as well, we're going to create a learning environment, that helps each one of us, sort of accelerate or find, the path to the careers, of their choice. And as such, you're going to find chemical analysis or advanced chemical analysis a highly interdisciplinary, type of course, which intersect in so many different types of industries, be it food industry, pharmaceutical industry, clinical diagnostics, many different, career paths. And as such, we should be able sort of to link, whatever career path you're interested in, to analytical chemistry. And so my goal really is to help that interlink and show you the relationships, between the skills that you're gonna learn in chemical analysis and how they can apply to very divergent fields that are represented, among the students community, that are seated here, because I believe most of us intend to go into different directions. And as such, chemical analysis really has got an interlink, to wherever you are going. So the learning ambience, I think most of you have attended my courses, particularly those of you who came from, the CHEM 211 stream. But nonetheless, I also understand there are students, who joined the course, from the CHEM 353 stream. And as such, you may not have encountered, my style of teaching. And so, what did you get yourself into, especially for you guys who don't know my style of teaching? I like to emphasize, that my classes have to be a safe, collaborative learning environment. Everyone is valued, everyone is respected, everyone's view should be expressed, and I encourage you to express it. That's the reason, for collaboration, really. That's a reason for collaboration, and everyone's view, should be expressed. And as such, I hope we're gonna have a very engaging, environment between me as your mentor, but also, among, the student peers, because we can learn a lot, from each other. And so my teaching philosophy really is, not to give you too much. I believe less is more. The less you're given, probably the more you can think about it. And so I really encourage you, especially in CHEM 311, to spend time to think about why you're learning the different concepts, that are gonna put across, because the course is fairly heavy actually in the course content. So I'm gonna make effort, to really distill it on it to what you really need to learn. The less is more, so that I don't really get you overwhelmed. But hopefully you get to have a lot of think time, about how these concepts, apply to the different fields of interest, that are fairly diversified really among the students. And so I believe actually in this psychologist's model that every student, can get an element or an environment, or the course can create an environment, where the content is fairly, stimulating, it's challenging enough, for you to be stimulated. It's not too, simple such that you get bored. So, challenging enough for you to be stimulated. Hopefully it connects a lot with what your interests are, and so you get yourself, interested, and so hopefully you get that element, of flow to see the relevance of the content that you are learning and the currency of the content that you are learning. And most of the content too, is fairly personalized. It's not just me feeding you with content, but I hope, especially, in the evaluation, and I'm gonna show you these, you guys are gonna do some research projects, some presentations. And so there's be an element of personal control, to contribute, to the knowledge, that is shared. So as such, it's an intersect, of mentor, myself, contributing to the knowledge, but also students, contributing their experiences and their presentations, to the pool of knowledge, And so I hope, it's gonna be an enjoyable, relaxing yet enjoyable, environment, to which you learn, with all these intersections, of knowledge from different directions. And as such, take time to think, why are we learning whatever we are learning? And how can it apply? And of course, there's divergency of applications, and that's a key. There's always divergency of applications, to whatever we learn. It can go in many, many different directions. And I am known to digress, and I wouldn't call it digressing. Every time I cover a chapter, hopefully I'm gonna show you different approaches, different prongs to which you can apply that concept, for different types of applications towards solving societal problems. And in fact, that divergence of application is really what sometimes, people call the art of innovation, taking a concept, that is mundane in a certain environment, but also applying it, to different types of areas, that it has not been applied before. A little further on my teaching philosophy, I believe that academy should be connected to industry. Most of us, most of you, are gonna end up, looking for a job in the industry. And so I believe, there should be an intersect between the theory, that we're gonna teach you in class and the practice that you're gonna learn in the lab, but in an academic environment, and hopefully show you how it connects, to real life, industry, where most of us, are gonna get hired. And I believe this is what you call translation of knowledge, into something that is relevant, to the community. And so I spend sort of quite a bit of time, helping students sort of, connect the relevance, the theory of what they are learning and how it applies, to the modern industry, and where hopefully most of you are gonna find employment. So I believe really students should be taking these courses again, so that the courses and the skill sets learned help them towards getting employment, or rather even creating jobs, through innovation in the chemical industry. Now, I should mention the following. You guys completing your education in a very disrupted job market. If you look at Alberta economy, and I don't want to be a pessimist, I'm more so an optimist, really. If you look at the Alberta economy, there's a distribution, of the revenue from different types of industries. You're gonna see predominantly, our economies still rely on the fossil fuels. And all of us know the trajectory, that is not very hopeful, to where the fossil fuels are going. I think there's already, an agreement, possibly among the economists and everyone else, that possibly we have reached, the peak of the fossil fuels demand. And going forward, you're certainly gonna see a decline, in the demand, of the fossil fuels, as the supply, from the green technologies, green energy technologies, take the place. And as such, and of course you've seen, the government of Alberta and the government of Canada trying to emphasize, the need to diversify and hopefully try to get substantially away from reliance, on the fossil fuels. But the status quo as it remains is that we are still very, very reliant, on the fossil fuels that don't have a very bright future. And that really impacts, the job market because of that reliance. And so you're graduating really, when we should be thinking about how, we should diversify the economy. And as such, you guys would be, the players, towards diversifying the economy and hopefully, looking for possibilities and opportunities outside, the fossil fuel industry. And so in Chem 311, I try a lot, hopefully to show you some of the different applications, beyond, really the fossil fuels, where each one of us, can find meaningful passions and employment, beyond the fossil fuels industry. So it's a good idea for us to really think beyond, the fossil fuel industry, and think also actually as a global citizen, in terms of where our skill sets, can be used, across the globe. as you well know, you're becoming really a global village. You can serve different you can use your skill sets in different geographical locations. And so to summarize all that, I hope CHEM 311 is gonna be, a piece of a puzzle together with all these other courses that possibly you guys are taking. And so I hope you develop some skill sets, that are gonna help you towards solving societal problems, that make you relevant, towards, getting a meaningful path, towards using those skill sets. And so I hope you develop, those critical skills that are so much needed in a very disrupted, job market. And if you look at Canada and the Western countries, there's what people call the innovation gap. The innovation gap. And the innovation gap really means, that our trajectory on technology and innovation, particularly in Canada, has gone down in comparison, of course, to the to other competitors, to the G7 countries, for example. And so I believe, some of these courses, like say CHEM 311, can help you develop, an innovation mindset, where, you move from just knowing, that's the theory, to doing, and we do a lot of that, in the lab, developing all these, practices and skills. And of course, that's what the industry really is looking for. What can you do? Not what you know. It's no longer what you know. It's what can you do with whatever you know. And that's where the application, the critical thinking, element lies. So that you can be whatever you choose to be in terms of solving societal problems, if at all you know how to apply the critical, skills that you learn, towards being. So hopefully, CHEM 311 is going to help you towards that path of not only knowing, but also doing, so that you can be and find your path, into the career of your passions. So very quickly, I'm going to go through, the critical elements, of the course outline and sort of, what the expectations are. Now, the lectures are designated, for Tuesdays and Thursdays, 12:30 to 1:30. Now, I'm going to be recording all the lectures and making them available, every week. So every week I'm going to post, 2 recorded lectures, and I'll be available to you as an office hour, during these designated, lecture times. So you're not required, to come during, these office hours, but I encourage you to drop in, and ask questions and so forth, okay? So the mode of delivery in this course is gonna be what they call asynchronous, okay? And that's what I've tried to explain, that I'm gonna post the recorded lectures, and you guys, can review them at your own given time. If at all you've got any questions, you can drop in during the office hours, which are during the designated lecture hours. I'm going to be available on Blackboard Collaborate. However, I must emphasize, there are some days that you'll be required, or all students will be required, to attend, the lecture hours, and that is when you are required to present. And I'm going to show you a couple of dates where there will be students' presentations, and so everyone is required to come, to the Blackboard Collaborate on those specific days, okay? So take note of those days, and I'm gonna flash them, as I go through the course outline, okay? I assume you're here because you got at least a minimum of C- in CHEM 311, or the other stream that you're coming from could be CHEM 353. And so I hope tomorrow, that means on January the 7th, as you share, as you introduce yourself, please comment on which stream you're coming from. Is it CHEM 211 or is it CHEM 353? Now the labs are gonna be face to face in room 5014. And the first lab is gonna be on January the 20th, from 12:30 p.m., to 4 p.m. The lab manual and the schedule is gonna be posted for you on Blackboard. It is required, that students complete 70% of the lab component for them to pass the CHEM 311 course. It's also required, just like CHEM 211, those of you who did CHEM 211, you know this, but those who did CHEM 353, good laboratory practices are a critical element in industry. And they are also a critical element in what we try to teach you in CHEM 311. Now, a critical aspect of good laboratory practices, the GLP as they call them, is how you record and document, your procedures and results in the lab. And as such, you're gonna need a physics, record book or lab notebook, which is gonna be graded, at the end of the semester, for your lab. So take note of that. You need a hard-covered physics, notebook, or at least a hard-covered notebook, for your labs. Of course, you're also gonna need, the lab coat and the other PPEs, such as the safety glasses and so forth. Now, I'm mainly gonna use this textbook, called Quantitative Chemical Analysis. Now, you're not required, to buy the textbook. I highly recommend it, but you don't have to buy. Okay, so the notes that I'm gonna provide are sufficient for you to pass the course. But if you want to, interrogate, the subject matter further, I encourage you, to read the Quantitative Chemical Analysis. Okay, now it's a fairly expensive textbook, and I understand if you're not able to buy one. In fact, I've got a couple of copies in my office, and you can take some, on a short loan. So if at all you want a copy, take it on a short loan, so long as, of course, you return it to me, at the end of the semester. Now, I also gonna often refer to these other textbook, though the Quantitative Chemical Analysis is gonna be the primary textbook. Sometimes I refer, to the Principles of Instrumental Analysis by Skoog, and sometimes I'm gonna refer some content, from that textbook. Sometimes people call it really, the compendium of analytical chemistry. If you do your PhD and so on, master's, graduate school, you're gonna find this is a textbook that you're gonna use for any analytical chemistry, especially instrumental analysis. Okay, but of course I don't expect you guys at all, to get one. So the course is fairly heavy in content, as you're gonna realize there are many instrumental methods out there. And so again, less is more. We're gonna focus on the most critical instrumental methods, such as analytical separations. And of course, there's a huge field, of analytical separations that I'm gonna summarize for you. We're gonna talk about different types of spectroscopies. Now, in CHEM 211, you guys covered a little bit of the UVV spectroscopy, but in this course, we're gonna cover the other types of spectroscopies, such as the X-ray, the OG, and so forth. We're also gonna cover things like, the Raman spectroscopy, the fluorescence spectroscopy that sort of was mentioned, in CHEM 211 and so forth. But one critical aspect that we really gonna focus on is how do you really distinguish between signal and noise, which is a critical aspect, of instrumental methods. And so that's gonna be our first chapter, distinguishing of signal to noise and the theory behind all that. You're also going to talk about the figures of merit. How do you relate signal from the instrument, to the concentration, which is what you are interested in, so calibrations. And those of you who did CHEM 211, again, you're very familiar with calibration, so things are going to be fairly straightforward for you as far as calibrations are concerned. But for the sake of those who did 353, I'm going to sort of repeat on calibrations. Again, remember, if you go to the industry, this is the crux of the matter. That's what you spend all your life doing, really, calibrations. Now, we're also going to talk about the figures of merit. And the figures of merit, refer to how do you evaluate, the performance, or what are the performance criteria of different analytical methods. And so based on the performance criteria, you can compare different analytical methods so that you choose the most appropriate analytical method, for a certain problem. Now, you're going to see most analytical chemists in the industry, that's what they mainly spend their time on, making decisions on which instrument would be appropriate for a certain problem. And so people use, what they call the figures of merit as indicators or an index of how to make that decision. And so we're going to talk a lot, about the figures of merit. And you guys, especially those of you from CHEM 211, sort of already know about them, limits of detection, limits of quantification, dynamic range, and so on, which we're going to talk about, in this course. And finally, we're going to talk about electroanalytical techniques. This is the future, really, of analytical chemistry. They are highly miniaturizable. You can make them into small sensors, like most of us are wearing possibly Fitbits and things like, smart watches, iPhone watches and all that. And actually, those are the basis. Those types of devices, I've got electroanalytical, sensors that can help them monitor, things like blood pressure, things like glucose in sweat, and so forth. And of course, that's the future, really. Sensors is the future, of analytical chemistry, because they're very, very small. You can distribute them, to do analysis of the point source, which is ideal, compared to the classical way of doing analysis, where you bring the sample into the lab, where the lab consists of very expensive instrumentation. So you're going to see the future is going towards small devices. And electroanalytical techniques are very adept, or they lend very well, for miniaturization, so that unskilled or the general public really can do analysis, in the field. Okay. So the key thing is, in all this content, I'd like you guys to really connect, and I'll show you, and we talk a lot about this, connecting the theory, to the applications, and of course being able to choose the appropriate method, for the right type of, the appropriate method, to analyze a problem. So it's going to be quite an important, learning outcome. So the list of experiments, to be covered, because of the pandemic, I've sort of shortened the number of experiments. So this semester, we only gonna do, really 5 different experiments. 4 of them in the lab, 2, 3, 4, 5 will be in the lab, in person. Now, the 6th experiment is gonna be virtual lab. You'll do that at home. And of course, the dry lab is going to be the very first assignment that I'm going to give you, so that you know how to do data manipulation, especially calibrations, which are very, very important, and which you got skills that you're going to really use in all these different other labs. So that's the very first sort of dry lab, which you're going to do. Again, you're going to do that at home because it's just data manipulation. And I'm going to talk to you about that, in due course. The other component, of the lab is that, you're going to do a research project. And the research project is gonna comprise up to 3 lab sections. So you're gonna do all these labs, but also a research project that's gonna account, for 3 lab sections. And you're gonna see that, in the schedule, that I provide you. And I'm gonna talk to you in the next couple of slides, about the research project in general, because this one account, for 20%, of your final marks. So very, very significant. And the whole goal of doing this is to get you acquainted, to doing for critical thinking, so that, the experimental procedures are not just given to you, but you develop your own experimental procedure. You go through the hypothesis, you're taught or you learn how to do the writing and so forth, scientific writing and presentation. That's going to be the component, of the research project. So maybe quickly to summarize, some of the learning outcomes. This course is going to be very light on calculations. It's going to be mainly on theoretical concepts, very few calculations. In fact, if I ask you to do a calculation, it's only going to be to demonstrate a concept. So the focus in the course is going to be mainly concepts. All right? And very few calculations. So the lectures, will discuss information, about different components of the instruments. Most students sometimes think of these instruments, they are Raman or a UV, as a black box. As an analytical chemist, we can't afford to think about it that way. And so we have to go right inside the instrument, and look at all the components and the theory behind all those components. And also determine, which components, determine the output, which is the signal. And how can you tweak or troubleshoot each component, so that it gives you the best signal, okay? So that's the reason for doing, this particular course, in terms of what can I change within the instrument, so that I can get the best signal. I should mention that some of the jobs available for analytical chemists is actually to make instruments. And partly that's what I did before, I became a professor. I was involved in development of instrumentation. And there's a huge area, of employment, where, an analytical chemist try to design, different components, say a detector, so that you can get increased, sensitivity or increased signal. So you're going to be looking at the theory behind each and every component in the different types of instrumentation, spectroscopies, mass spectroscopy, X-ray spectroscopy, HPLC and so forth, and how it determines, the results that you get. In the labs, we're going to explore the concepts, related to the instrumentations with regard to how they are applied, towards solving analytical problems. So hopefully you're going to see the connection between the theory, and the practice when you go to the lab. Now, there will be assignments, which involve reading journal articles. And this one relates also to the research project and presenting it in class. Also the research project, when you develop or design the experiments, and actually execute them in the lab and then present it, to the class or disseminate it in form of a presentation as well as a thesis, which again, I'm going to give you more details on that. And again, the goal for the research project is to apply the knowledge learned, so that you can solve a societal problem. Now, in this course, it's expected, that you are progressing towards being an independent chemist. And for that reason, that's why, for example, in the research project, we're going to get you to actually, develop, or design the experiments, and not just given, a procedure, but you develop your own procedure. And that hopefully helps you towards independence, as a chemist, because of course, when you go to the industry, there'll be a responsibility really to design, the project. There'll be a responsibility, to report the data. There'll be a responsibility, to do all these things, And so hopefully the research projects help you towards that path of being an independent, critical thinking, chemist. Now you're also gonna find, unlike Chem 211 and maybe 353, some of the information will be missing in the labs, in the regular labs. And this one is intentional, so that you get to think, about how do you solve a problem. I'll give you an example. Now, instead of being given, say, 1 molar of sulfuric acid, maybe what I'm gonna give you is 38% sulfuric acid. And it will be a responsibility, to determine how do you dilute, 38% sulfuric acid, to 1 molar sulfuric acid, which you are asked to use in the lab. So it wouldn't be completely spoon feeding, like in the Chem 211. Again, for the purpose of, getting you to be a lot more independent, towards the path you're going of finishing and going to the industry, where you're required to be the one to provide guidance, on these things. And again, as I've mentioned, we're going to talk a lot about instruments and its components and how that impacts the figures of merit and how you are required, to choose a certain method, of another, and what you need to do that is to, be aware of the figures of merit and how to apply them. So in the next chapter or sort of lecture, I'm going to talk to you again a little more, about the research projects, because I'm confident most of you have got a lot of questions about, the research project, the 20% research project. How is that going to look like? And hopefully I'm going to answer your questions, about that in the next lecture.